Picture this. You're staring into the blackest night sky you've ever seen, where a single speck of light represents not just a star, but an entire galaxy containing billions more stars. Now imagine that light traveled for over 13 billion years just to reach your eyes tonight. That's not science fiction, that's the reality of our universe. Across unimaginable distances and unfathomable stretches of time, galaxies we're only beginning to understand are sending us whispers from the cosmic dawn. What if I told you some of these galaxies shouldn't exist according to our current laws of physics? That black holes formed faster than scientists thought possible. That entire galaxies move away from us faster than the speed of light itself. Buckle up, because we're about to take you on a journey to the very edge of observable reality with 50 mind-bending facts about the universe's most distant galaxies. By the time we're done, you'll never look at the night sky the same way again. These aren't just distant specks of light, they're time capsules showing us the universe in its infancy, challenging everything we thought we knew about space, time, and existence itself. Ready to have your mind stretched across 13.8 billion years of cosmic history? Then let's begin. Now let's zoom out to the grandest scale imaginable. The observable universe isn't just vast, it's almost incomprehensibly packed with galaxies. For decades, scientists believed there were around 100 billion galaxies out there. But recent discoveries have shattered that estimate. Thanks to deep field observations by telescopes like Hubble, we now know the observable universe contains at least 2 trillion galaxies. That's 2,000 billion galaxies, each one a swirling island of stars, planets, and cosmic mysteries. And here's what's even more mind-blowing: most of these galaxies are ancient, faint, and incredibly far away. They're so distant that their light has been traveling for billions of years just to reach us, meaning we're seeing them as they were when the universe was young. Some are so remote that they exist right on the edge of what we can observe, their light stretched and dimmed by the relentless expansion of space itself. Think about that for a second. Every time you look up at the night sky, you're not just seeing stars, you're glimpsing a fraction of a cosmic ocean filled with trillions of galaxies, each with its own story. And the wildest part, this is just the universe we can see. Beyond our observational limits, there could be infinitely more, hidden forever by the sheer scale of space and time. So next time you feel small under the stars, remember, you're standing in a universe so enormous, it defies even our boldest imaginations. Now, let's turn our gaze to one of the most astonishing discoveries in modern astronomy, the galaxy known as GNZ 11. This ancient cosmic beacon holds the record as the oldest and most distant galaxy ever observed, dating back to a mere 400 million years after the Big Bang. To put that into perspective, this galaxy was already shining when the universe was just 3% of its current age. What makes GNZ 11 so special isn't just its age, it's the secrets it reveals about the early universe. Astronomers identified it using the Hubble Space Telescope, but it was the galaxy's redshift value that truly stunned them. Redshift, the stretching of light as the universe expands, is how we measure cosmic distances. GNZ 11's redshift is an incredible 11.1, meaning its light has been traveling for over 13.3 billion years to reach us. That's almost the entire history of the cosmos itself. But here's where it gets even more fascinating. Despite being so young in cosmic terms, GNZ 11 is surprisingly bright and packed with stars. This challenges our assumptions about how quickly galaxies could form after the Big Bang. Scientists expected the earliest galaxies to be small and dim, but GNZ 11 defies that idea, suggesting that star formation in the infant universe was far more intense than we imagined. This discovery doesn't just rewrite the timeline of galaxy formation, it opens a window into an era known as cosmic dawn, when the first lights in the universe flickered to life. GNZ 11 is like a time capsule, showing us a snapshot of a universe still in its infancy. a place where the first building blocks of everything we know were just beginning to take shape. And with the James Webb Space Telescope now peering even deeper into the past, who knows what other ancient giants are waiting to be uncovered? Now, let's tackle one of the most mind-bending truths about our universe, the fact that some galaxies are racing away from us faster than the speed of light. At first glance, this seems impossible. After all, nothing can surpass light speed, right? Well, here's the cosmic twist. It's not the galaxies themselves moving through space at that velocity. Instead, it's the very fabric of the universe stretching between us and them, carrying those galaxies along like raisins in an expanding loaf of bread. This phenomenon is all thanks to cosmic expansion, a discovery that reshaped our understanding of the universe. The farther away a galaxy is, the faster space itself pushes it away from us. Beyond a certain point, about 14 billion light-years, the expansion becomes so extreme that those galaxies vanish from our view. Their light, no matter how bright, can never reach us because the space between us is growing faster than light can traverse it. Think of it like a cosmic treadmill set to an impossible speed. Even if a distant galaxy shines its light toward us, the stretching space between us outpaces that light, dooming it to fade into oblivion. This is why we'll never see the full universe, only the observable part where light still has a fighting chance to reach our telescopes. But here's the kicker: this doesn't break Einstein's rule that nothing can travel through space faster than light. The galaxies aren't moving through space at that speed. Space itself is expanding, carrying them away. It's a subtle but crucial distinction that keeps physics intact while revealing just how strange and vast our universe truly is. So while these ultra-distant galaxies slip forever beyond our cosmic horizon, they leave behind a profound lesson. The universe isn't just big, it's growing in ways that defy our everyday intuition. And every galaxy we can see is a fleeting glimpse into a past that's racing away from us, one expanding light year at a time. Now, here's something that's left astronomers scratching their heads. Some of the most distant galaxies we've spotted shouldn't even exist according to our current understanding of the cosmos. Thanks to the Hubble Space Telescope and its powerhouse successor, the James Webb Space Telescope, we're seeing galaxies so ancient and bright that they're throwing a wrench into our best theories about how the early universe worked. These telescopes act like cosmic time machines, peering back to an era just a few 100 million years after the Big Bang. But what they've found is startling galaxies brimming with stars, packed tightly together and shining with an intensity that defies expectations. According to most models, the universe was still too young for galaxies to have grown that large or that luminous so quickly. It's like finding a fully grown tree in a forest that's only been sprouting for a week. So why does this matter? Because it forces scientists to rethink how galaxies formed in the universe's infancy. Maybe stars ignited faster than we thought, or perhaps dark matter played a more dramatic role in clumping matter together. Some researchers are even questioning whether we need to tweak the timeline of cosmic dawn itself. What's truly exciting is that every new observation from these telescopes adds another piece to the puzzle. With each galaxy that shouldn't be there, we're pushed closer to rewriting the story of how the universe built its first cities of stars. And that's the beauty of astronomy. Sometimes the most unexpected discoveries are the ones that teach us the most. Now let's step even further back in time, to a pivotal moment when the universe flickered to life after eons of darkness. This was the cosmic dawn, the era when the first galaxies ignited, flooding the cosmos with light and ending what astronomers call the cosmic dark ages. Picture a universe so young that it was shrouded in a thick fog of hydrogen gas, blocking all light. Then, like the first sparks in a vast, empty night, stars and galaxies began to form, their intense radiation burning away the fog in a process known as reionization. This wasn't just a gentle sunrise, it was a revolution. The energy from those early galaxies ripped electrons from hydrogen atoms, transforming the universe from opaque to transparent. Think of it as lifting a cosmic curtain, allowing light to travel freely for the first time. Without this dramatic shift, the light from galaxies we see today would still be trapped, and the universe would remain invisible to us. What's truly fascinating is how quickly this happened. In cosmic terms, reionization was like flipping a switch, lasting just a few 100 million years. But how? The leading theory points to those first galaxies, packed with massive, short-lived stars that blazed brilliantly and died young, spewing ultraviolet radiation that cleared the cosmic haze. Some researchers also suspect quasars, supermassive black holes at the centers of early galaxies, played a role, their jets acting like cosmic blowtorches. Yet mysteries remain. Were galaxies alone responsible, or did other forces contribute? Why did reionization happen faster in some regions than others? Each answer we uncover peels back another layer of the universe's origin story. And as telescopes like James Webb peer deeper into this epoch, we're not just observing history, we're rewriting it, one glowing galaxy at a time. Now, here's something that might surprise you. Those ancient galaxies lighting up the early universe weren't the colossal giants we often picture. Instead, many were surprisingly small, some no bigger than a fraction of our Milky Way. But don't let their size fool you. These cosmic fireflies packed an incredible punch, shining with a brilliance that defies their modest scale. So, what made these tiny galaxies so dazzling? The answer lies in their chaotic, high-energy youth. Picture a stellar nursery gone wild, gas clouds collapsing at breakneck speed, birthing stars hundreds of times faster than modern galaxies. In these cramped, frenzied environments, massive stars flared to life in rapid succession, burning hot and bright before exploding as supernova, seeding the cosmos with even more light. It's like comparing a quiet campfire to a roaring bonfire doused in gasoline. The intensity is on another level. But stars weren't the only players. At the hearts of many of these galaxies lurked supermassive black holes, though supermassive might be an understatement. These monsters, growing at unbelievable rates, devoured surrounding matter and unleashed torrents of energy as quasars, some of the brightest objects in the universe. Their radiation alone could outshine entire galaxies, adding to the cosmic fireworks. This combination, breakneck star formation and ravenous black holes, turned these compact galaxies into beacons visible across billions of light years. And here's the kicker, their small size actually helped. With less distance for light to travel before escaping, their glow wasn't stifled by dust or gas, making them even more luminous to our telescopes. It's a reminder that in the early universe, bigger didn't always mean brighter. Sometimes the most dazzling lights came in the smallest packages. Now, let's talk about one of the universe's most fascinating tricks, gravitational lensing. Imagine light from a distant galaxy traveling across the cosmos for billions of years, only to be bent and magnified by an invisible cosmic magnifying glass. That's exactly what happens when a massive object like a galaxy cluster warps the fabric of space-time itself, as predicted by Einstein's theory of relativity. This cosmic distortion acts like a natural telescope, amplifying the light of galaxies so far away they'd otherwise be invisible to even our most powerful instruments. Sometimes the effect is so dramatic that a single distant galaxy appears as multiple arcs or rings around the foreground cluster, a stunning visual echo of the universe's hidden geometry. But gravitational lensing isn't just a pretty illusion. It's a vital tool for astronomers, allowing them to peer deeper into space and time than ever before. By studying these distorted images, scientists can map the distribution of dark matter, the invisible scaffolding that holds galaxies together, and even measure the expansion rate of the universe. The best part, some of the most distant galaxies we've ever discovered were only spotted thanks to this cosmic quirk. Without gravitational lensing, their faint whispers of light would have been lost in the vast darkness. So next time you see a warped galaxy in a telescope image, remember, you're not just looking at light, you're seeing space itself bend to reveal the universe's best-kept secrets. Now, let's pull back the curtain on one of the universe's greatest mysteries, dark matter. While we can't see it directly, this invisible material played the ultimate cosmic architect, shaping the very first galaxies in existence. Picture the early universe as a vast, empty construction site. Dark matter was the unseen framework, the gravitational glue that pulled together the first wisps of gas and dust, setting the stage for stars and galaxies to ignite. Without dark matter, those primordial galaxies might never have formed. Its gravity created dense pockets in the fabric of space, acting like cosmic gathering points where ordinary matter could pool and collapse. Over time, these swirling pools of gas grew hotter and denser until boom, the first stars flickered to life, lighting up the darkness. Here's the wild part: dark matter didn't just build the scaffolding, it dictated the blueprints. The distribution of dark matter determined whether early galaxies would be clumpy and irregular or take on more structured shapes. Even today, dark matter's invisible embrace continues to hold galaxies together, preventing them from flying apart as they spin. So while we may never see dark matter directly, its fingerprints are everywhere. From the tiniest dwarf galaxies to the largest clusters, this ghostly material remains the universe's unsung hero, quietly shaping the cosmos since the very beginning. Now, let's step even further back in time to witness the cosmic chaos of the early universe. Unlike the elegant spirals and smooth ellipticals we admire today, the first galaxies were messy, turbulent places. Imagine a toddler's first attempt at drawing a galaxy, splotchy, uneven, and bursting with raw energy. That's what many of these ancient galaxies looked like. Back then, gravity was still trying to bring order to the universe. Gas and stars swirled in erratic clumps, colliding and merging in a frenzied dance. There were no defined arms or symmetrical shapes, just a wild jumble of star-forming regions blazing with intense light. These galaxies were smaller, too, often no bigger than a tenth of our Milky Way, but they burned fiercely, churning out stars at rates far beyond what we see in modern galaxies. What caused this chaos? For one, the universe itself was denser and more crowded, with galaxies frequently bumping into each other. Plus, without the heavy elements forged by generations of stars, early galaxies lacked the cosmic glue to stabilize their structures. Over billions of years, as mergers smoothed out their shapes and star formation slowed, these unruly youngsters matured into the orderly galaxies we recognize today. So next time you gaze at a perfect spiral galaxy, remember, its serene beauty is the result of eons of cosmic evolution, a far cry from the raucous beginnings of the universe's first galactic pioneers. But just when we thought we'd glimpsed the edge of cosmic history, astronomers shattered records yet again. Meet HD1, the most distant galaxy ever observed, a faint smudge of light that rewrote our understanding of the early universe. Discovered in 2022, this ancient beacon is so far away that its light spent 13.5 billion years racing across the cosmos before reaching our telescopes. To put that into perspective, HD1 existed when the universe was a mere 330 million years old, a cosmic toddler taking its first steps. Spotting it was like finding a single candle flame flickering at the edge of the observable universe. Scientists used the combined power of the Hubble Space Telescope, the Subaru Telescope, and other observatories to detect its telltale redshift, a staggering value of 13.3, far beyond previous record holders like GNZ11. What makes HD1 even more astonishing is its puzzling brightness. Some theories suggest it might harbor population 3 stars, the universe's very first stars made purely of hydrogen and helium. These hypothetical giants would have burned ferociously hot and died young, flooding space with ultraviolet light that could explain HD1's intense glow. Alternatively, it might host a supermassive black hole already weighing 100 million suns. an idea that challenges everything we know about how quickly such monsters could form after the Big Bang. Either way, HD1 forces us to rethink the timeline of cosmic dawn. How did galaxies or black holes grow so large so fast? With the James Webb Space Telescope now trained on this enigmatic object, we're closer than ever to unraveling its secrets. One thing's certain, the deeper we peer into the past, the more the universe surprises us. Now, let's turn our attention to one of the most baffling cosmic discoveries, supermassive black holes that existed shockingly early in the universe's history. These monstrous giants, some weighing billions of times the mass of our Sun, shouldn't have had enough time to grow so enormous so quickly after the Big Bang. Yet they're there, lurking in the hearts of distant galaxies, defying our expectations. Take the quasar J1342 plus 0928, for example. This blazing beacon of light, powered by a supermassive black hole, was spotted in a galaxy so ancient that it existed when the universe was just 690 million years old. That's like finding a fully grown blue whale in a newborn's bathtub. It simply shouldn't be possible under our current understanding of black hole growth. Scientists are scrambling to explain how these cosmic heavyweights formed so fast. One theory suggests they might have started as seed black holes left behind by the collapse of the universe's very first stars. But even then, they'd need to devour matter at near impossible rates to reach such staggering sizes in such a short time. Another wild idea, that supermassive black holes could have formed directly from collapsing clouds of primordial gas, skipping the star stage entirely. The James Webb Space Telescope is now hunting for more of these early black holes, peeling back the layers of cosmic history to uncover their origins. Each discovery pushes the boundaries of what we thought was possible, reminding us that the early universe was far more dynamic and far stranger than we ever imagined. Now, let's explore one of the most dramatic processes in cosmic history, galactic cannibalism. Just like predators in the wild, the biggest galaxies in the universe grew by devouring smaller ones. This violent but fascinating process played a crucial role in shaping the galaxies we see today. In the early universe, galaxies were much closer together, making collisions far more common. When two galaxies merged, gravity would pull them into a chaotic dance, stretching their stars and gas into long, swirling tails. Over millions of years, the smaller galaxy would be torn apart and absorbed by the larger one, fueling its growth. Our own Milky Way is no stranger to this cosmic feast. Astronomers have found evidence of past mergers in the form of stellar streams, ghostly trails of stars left behind by galaxies it consumed. And it's still happening today. The Milky Way is currently pulling in the Sagittarius dwarf galaxy, a small neighbor that will eventually become part of our galactic home. But mergers weren't just about size, they also transformed galaxy shapes. Many of the majestic spiral galaxies we admire, like Andromeda, likely started as clumpy, irregular blobs. Repeated collisions smoothed them into their iconic forms. Meanwhile, the largest galaxies in the universe, giant ellipticals, grew into their enormous sizes by gobbling up countless smaller galaxies over billions of years. These galactic mergers also had another side effect. They triggered intense bursts of star formation. When galaxies collided, their gas clouds compressed, igniting a firestorm of new stars. Some of the brightest galaxies in the distant universe owe their brilliance to these violent encounters. So the next time you gaze at a galaxy, remember, its majestic shape and size might just be the result of a cosmic feeding frenzy that began billions of years ago. Now, let's unravel one of astronomy's most powerful tools, redshift. This cosmic measuring tape allows scientists to peer back in time, revealing not just how far a galaxy is, but also how old its light truly is. Here's how it works. When light travels across the expanding universe, its wavelengths stretch, shifting toward the red end of the spectrum, like the sound of a passing ambulance siren dropping in pitch. The farther the light travels, the more extreme this redshift becomes. Astronomers measure this shift to calculate a galaxy's distance, but redshift does more than just map space, it's also a time machine. A high redshift means the light has been journeying for billions of years, offering a snapshot of the galaxy's youth. For example, the galaxy GNZ 11, with a redshift of 11, shows us what galaxies looked like just 400 million years after the Big Bang. This technique has revolutionized our understanding of cosmic history. Without redshift, we'd have no way to distinguish nearby galaxies from ancient ones billions of light years away. It's the key that unlocked the true scale of the universe and the staggering age of its most distant inhabitants. So next time you hear about a far-off galaxy, remember, its redshift isn't just a number. It's a timestamp from the dawn of time itself. Now, let's turn our attention to a cosmic puzzle: galaxies that have seemingly given up on life. Imagine a bustling city that suddenly falls silent, its streets empty and lights dimmed. That's what astronomers see when they spot dead galaxies in the distant universe, stellar metropolises where no new stars are born. These galaxies burn through their star-forming gas at breakneck speed, shutting down production billions of years earlier than expected. Take MAX 2129-1 for example. This massive galaxy stopped forming stars when the universe was just 2 billion years old, leaving behind a relic of aging stars with no young replacements. Scientists call this phenomenon quenching, and it defies our models of how galaxies evolve. Why the sudden shutdown? One theory points to supermassive black holes at galactic centers. As these monsters feast on surrounding material, they unleash torrents of energy that heat up or blow away the cold gas needed to create stars. Another possibility is that rapid star formation itself exhausted the fuel supply too quickly, like a wildfire consuming all available oxygen. The James Webb Space Telescope has spotted even more of these red and dead galaxies in the early universe, deepening the mystery. Their existence suggests that some galaxies live fast and die young, collapsing into retirement, while others, like our Milky Way, keep churning out stars for billions of years. This cosmic burnout challenges our understanding of galaxy life cycles. Were these galaxies doomed by their environment, or did internal chaos seal their fate? Every lifeless galaxy we find adds another piece to this intriguing puzzle. But here's something even more fascinating. What if we told you the universe has its own hidden light? A faint glow that whispers secrets about galaxies we can't even see. This cosmic background glow, especially in infrared light, acts like a fingerprint of countless distant galaxies lurking just beyond our telescope's reach. Think of it like standing in a foggy forest at night. You might not see every tree, but the faint glow of distant lanterns hints at how vast the woods truly are. Similarly, when astronomers measure the universe's infrared background, they're picking up the combined light of billions of galaxies too dim or too far away to spot individually. Some of these galaxies are so ancient, their stars formed when the universe was in its infancy, yet their faint light has been traveling for billions of years to reach us. The Spitzer Space Telescope and later the James Webb Space Telescope have played detective with this cosmic glow. By analyzing its subtle fluctuations, scientists estimate that up to half the galaxies in the early universe remain hidden from our direct view, cloaked in dust or simply too distant for current technology. Some might be the very first galaxies, their light stretched and dimmed by cosmic expansion into near invisibility. This discovery reshapes our cosmic senses. If so many galaxies are hiding in plain sight, what else are we missing? The universe's background glow isn't just noise, it's a treasure map pointing to uncharted realms waiting to be explored. Now, let's zoom out and see the universe on its grandest scale, because galaxies don't just float randomly in space. They're strung along invisible cosmic highways, vast threads of dark matter and gas that weave the entire universe into a colossal web. These filaments, stretching hundreds of millions of light-years, are the scaffolding of creation, guiding galaxies into place like beads on a string. Picture it like a city subway system where dark matter acts as the tracks and galaxies cluster at the busiest intersections. The largest of these intersections, where multiple filaments meet, become the homes of massive galaxy clusters, cosmic metropolises teeming with stars. Meanwhile, the thinner threads feed smaller galaxies, funneling gas and dust to fuel new stars. This cosmic web wasn't just born overnight. In the early universe, tiny fluctuations in matter, seeds planted by the Big Bang, grew denser over billions of years, pulled together by gravity. Dark matter, invisible yet dominant, shaped these filaments first, with ordinary gas and galaxies following its lead. Today, telescopes like Hubble and simulations like the Illustris project reveal this intricate architecture, showing how galaxies are born and move along these hidden roads. But here's the twist: these filaments aren't just passive structures. They hum with activity, channeling superheated gas between galaxies and even triggering star formation when they collide. Some filaments are so massive they bend space-time itself, acting as gravitational lenses that magnify distant objects behind them. So the next time you gaze at the night sky, remember, you're not just looking at stars. You're seeing a single thread in the universe's grand tapestry, woven together by forces we're only beginning to understand. Now, let's turn our attention to a celestial marvel that defies expectations: the Butterfly Galaxy. This distant starburst galaxy, officially known as Messier 96, is a whirlwind of cosmic activity, churning out new stars at a rate that leaves astronomers in awe. Nestled roughly 35 million light-years away in the constellation Leo, this galaxy earns its nickname from its delicate, wing-like spiral arms, which shimmer with the glow of countless young, hot stars. What makes the Butterfly Galaxy so extraordinary isn't just its beauty, it's the sheer intensity of its star formation. While our Milky Way produces maybe 1 or 2 new stars a year, this galaxy is a veritable stellar factory, birthing stars at a rate hundreds of times faster. Imagine a cosmic fireworks display where pockets of gas collapse under gravity, igniting into brilliant new suns in a relentless cycle of creation. This frenzy of activity offers a rare glimpse into the conditions of the early universe. Starburst galaxies like this one are thought to resemble the first galaxies that lit up the cosmos, when the universe was younger and richer in the raw materials needed for star birth. The Butterfly Galaxy's extreme environment, where dense clouds of gas collide and compress, mirrors the chaotic, high-energy conditions that dominated the universe billions of years ago. But here's the puzzle: why is this galaxy so active now? One leading theory suggests a recent close encounter with a neighboring galaxy, whose gravitational pull may have sent shockwaves through the Butterfly Galaxy's gas clouds, triggering this explosive star formation. It's a reminder that even in the vastness of space, interactions between galaxies can spark dramatic change. So the next time you spot the constellation Leo, remember within its boundaries lies a cosmic butterfly, fluttering with the energy of a universe in its youth. Now let's journey even deeper into the cosmos to uncover one of the universe's most dazzling phenomena: quasars. These brilliant beacons shining from the farthest reaches of space are the ultra-bright cores of distant galaxies powered by supermassive black holes. Imagine a single object so luminous it outshines an entire galaxy, yet compact enough to fit within our solar system. That's the staggering power of a quasar. At the heart of every quasar lies a supermassive black hole, millions to billions of times heavier than our Sun. But unlike the silent voids we often picture, these black holes are anything but dormant. As they devour surrounding gas, dust, and even stars, the material spirals inward at incredible speeds, heating up to millions of degrees and glowing intensely before vanishing beyond the event horizon. This process creates an accretion disk, a swirling, superheated maelstrom that radiates more energy than a trillion suns. What makes quasars especially fascinating is their role as cosmic lighthouses. Because they're so extraordinarily bright, they can be seen across mind-bending distances, even from the edge of the observable universe. The light from the most distant quasars has traveled over 13 billion years to reach us, offering a direct glimpse into the universe's infancy. In fact, quasars are so pivotal that astronomers use them to map the large-scale structure of the cosmos, illuminating the vast web of galaxies and dark matter that stretches across space. But here's the twist: quasars aren't eternal. They're a fleeting phase in a galaxy's life, lasting perhaps a few 100 million years. Once the black hole consumes most of the nearby fuel, the quasar dims, leaving behind a quieter galactic core. This means the quasars we observe today are snapshots of a violent, energetic youth, both for the galaxies hosting them and the universe itself. So the next time you hear about a quasar, remember, you're not just looking at a distant light. You're witnessing the fiery adolescence of the cosmos, a time when black holes ruled the skies and galaxies were just finding their way. Now, let's turn our attention to one of the universe's most puzzling mysteries, the Great Attractor. Picture this: countless galaxies, including our own Milky Way, are being pulled toward an invisible point in space with unimaginable force. But what exactly is tugging at them? Scientists have been chasing this cosmic enigma for decades, and the answers might reshape our understanding of the universe. At the heart of this mystery lies a gravitational anomaly so powerful it bends the paths of entire galaxies. Located roughly 250 million light-years away in the direction of the constellations Centaurus and Hydra, the Great Attractor exerts a pull strong enough to override the expansion of the universe itself. For years, its true nature remained hidden behind the dense plane of our own galaxy, where dust and stars obscured our view. What makes this even more fascinating is that the Great Attractor isn't acting alone. Recent observations reveal it's part of something far larger, a colossal supercluster of galaxies known as Laniakea, which means immense heaven in Hawaiian. This vast cosmic structure, spanning 500 million light-years, acts like a gravitational anchor, drawing galaxies into its web. Yet, even Laniakea seems to be moving toward an even more massive concentration of matter, nicknamed the Shapley Attractor, hinting at an endless hierarchy of cosmic pulls. So why does this matter? Because the Great Attractor challenges our assumptions about how mass is distributed in the universe. If visible matter alone can't account for its gravitational grip, could dark matter, or something even stranger, be at play? Every galaxy caught in this flow carries clues, helping astronomers piece together the hidden architecture of the cosmos. The next time you gaze at the night sky, remember, our galaxy isn't just drifting aimlessly. It's part of an immense cosmic dance guided by forces we're only beginning to understand. And somewhere out there, the Great Attractor keeps pulling, reminding us that the universe still holds secrets waiting to be uncovered. Now, here's something that defies everything we thought we knew about galaxies. Some of them don't just fade away forever. Imagine a galaxy that's essentially hit the cosmic off switch, its star-forming gas exhausted, leaving it dark and dormant. But then, against all odds, it roars back to life billions of years later, reigniting with a burst of new stars. How is that even possible? Astronomers have spotted these galactic phoenixes scattered across the universe, and their existence flips the script on galaxy evolution. Take, for example, a galaxy that went quiet more than 10 billion years ago. Its star-forming factories shut down. Then, somehow, it found a fresh supply of gas, perhaps by colliding with another galaxy or siphoning fuel from intergalactic space, and suddenly, it's ablaze with stellar nurseries again. This isn't just a rare fluke, it's a phenomenon that's forcing scientists to rethink how galaxies live, die, and sometimes cheat cosmic death. What's even wilder is that some of these revived galaxies shouldn't have had a second chance at all. In the early universe, gas was thought to be too hot and scattered for dormant galaxies to reclaim it, yet here they are, defying the odds. Could hidden reservoirs of cold gas be lurking in the cosmic shadows, waiting to reignite these sleeping giants? Or are supermassive black holes at their centers somehow stirring the pot, pulling in fresh material and sparking new life? This discovery isn't just a curiosity, it's a clue. If galaxies can resurrect themselves, it means the universe is far more dynamic than we imagined. The story of galaxies isn't a straight line from birth to death. It's a roller coaster of pauses, reboots, and surprises. And that raises a thrilling question. If long-dead galaxies can wake up, what other cosmic rules might be waiting to be rewritten? Speaking of rewriting the rules, let's turn our attention to another cosmic marvel, a distant galaxy that mirrors our own Milky Way in its youth. But that's a story for another moment. Now, let's journey to a galaxy that acts like a cosmic time capsule, the Sparkler Galaxy. Picture this, a distant, shimmering collection of stars and clusters that looks eerily familiar, almost like a younger version of our own Milky Way. Astronomers call it the Sparkler Galaxy because of its dazzling, compact clusters that glow like tiny cosmic fireflies. But here's the real kicker. This galaxy is a snapshot of what our home galaxy might have looked like when the universe was just a toddler, around 4 billion years old. What makes the Sparkler Galaxy so special? For starters, it's packed with globular clusters, dense groups of ancient stars that orbit its core, much like the ones we see in the Milky Way today. But in the Sparkler, these clusters are still in their infancy, giving us a front-row seat to how our galaxy's own star clusters might have formed billions of years ago. It's like finding a childhood photo of the Milky Way frozen in time and space. The James Webb Space Telescope played a key role in this discovery, peering through cosmic dust and gas to reveal the Sparkler's secrets. By studying its structure and composition, scientists have pieced together a startling theory. The Milky Way likely started as a small, chaotic galaxy, just like the Sparkler, before growing into the grand spiral we know today. Those glittering clusters, they're the building blocks of larger galaxies, the seeds that eventually merged and settled into the orderly patterns we see now. But the Sparkler Galaxy isn't just a mirror. It's also a mystery. Why do some of its clusters appear so much brighter and bluer than others? Could they be the remnants of smaller galaxies it swallowed along the way, just as the Milky Way did in its past? Every detail we uncover adds another piece to the puzzle of how galaxies evolve and how our own cosmic neighborhood came to be. So the next time you gaze up at the Milky Way's shimmering band of light, remember, it wasn't always this majestic. It began as a sparkler too, flickering in the darkness of the early universe, waiting to grow into the galaxy we call home. And speaking of growth, let's turn to another cosmic heavyweight, one that defies expectations by packing enormous mass into a surprisingly tiny space. Now let's tackle one of the most puzzling mysteries in modern astronomy, the case of the universe's missing galaxies. According to supercomputer simulations of the early cosmos, there should be far more small, faint galaxies scattered across the universe than what our telescopes have actually detected. It's like expecting a crowded room but walking in to find only a handful of people. So where is everyone? This discrepancy has scientists scratching their heads. The simulations, which model how dark matter and gas should have clumped together after the Big Bang, predict a universe teeming with tiny, primordial galaxies. Yet when we peer deep into space with telescopes like Hubble and James Webb, many of these expected galaxies simply aren't there. Some researchers call this the missing satellites problem, because these galaxies should orbit larger ones like moons around a planet, but they're conspicuously absent. One leading theory suggests these galaxies do exist, but they're just too dim for us to spot. Early galaxies might have been starved of gas, making them fainter than predicted, or perhaps their light is hidden behind thick cosmic dust. Another possibility, our simulations overestimate how efficiently gas collapsed into stars in the early universe, meaning fewer galaxies formed than we thought. But here's where it gets even stranger. Some scientists argue that dark matter, the invisible glue holding galaxies together, might behave differently than we assume. If dark matter particles interact with each other or with regular matter in unexpected ways, it could explain why fewer galaxies formed. Others propose that intense radiation from the first stars might have blasted away gas needed to form new galaxies, leaving behind a quieter cosmic landscape. Every missing galaxy is a clue waiting to be found. As telescopes grow more powerful, we might finally spot these elusive cosmic ghosts or rewrite our theories entirely. Either way, this puzzle reminds us that the universe still holds plenty of surprises. And speaking of surprises, let's turn to another head-scratcher, a galaxy so ancient it shouldn't have had time to cook up the ingredients for life as we know it. Now, let's zoom in on a discovery that rewrote the cosmic rulebook: oxygen found in a galaxy so old, it shouldn't have had time to brew such heavy elements. This galaxy, known as MAX 1149 JD1, dates back a staggering 13.3 billion years, meaning we're seeing it just 500 million years after the Big Bang. Here's the twist: oxygen, a key ingredient for life as we know it, shouldn't have existed in such abundance that early. How did it get there? The answer lies in the frenzied lives and explosive deaths of the universe's first stars. These pioneers, called Population 3 stars, were giants hundreds of times more massive than our Sun, and they burned bright and fast. Within a few million years, they detonated as supernova, scattering oxygen and other heavy elements into the cosmos like cosmic sprinkles. For oxygen to show up in MAX 1149 JD1 so soon after the Big Bang, these stars must have formed, lived, and died in a blink of cosmic time. This discovery flips our understanding of the early universe. Instead of a slow, gradual buildup of elements, it suggests a period of rapid chemical enrichment, like a cosmic kitchen working at warp speed. Telescopes like ALMA, which spotted the oxygen's faint fingerprint, reveal that galaxies were already bustling with star formation and stellar death far earlier than we'd imagined. But here's the real kicker. If oxygen existed that early, other life-critical elements like carbon and nitrogen might have been brewing too. That means the building blocks for planets and potentially life could have been available much sooner in the universe's history than anyone predicted. It's a humbling reminder that the cosmos doesn't always follow our timelines, and as we push our telescopes to peer even further back, who knows what other elemental surprises are waiting in the shadows of the early universe. Speaking of cosmic shadows, let's turn our attention to another distant oddity, a galaxy so faint and spread out, it defies everything we know about galactic structure. Now, let's meet one of the universe's most puzzling galactic rebels, the Dragonfly Galaxy. This distant oddity, officially known as Dragonfly 44, doesn't look like any galaxy you've seen before. Forget the classic spiral arms or the smooth, rounded shape of ellipticals. This one is a ghostly, wispy enigma, stretching across space like a delicate cosmic web. What makes Dragonfly 44 so bizarre? Most of its mass isn't even in stars, it's in something invisible, dark matter. In fact, this galaxy is about 99% dark matter, making it nearly as massive as our Milky Way but with only 1% of the stars. Imagine a city the size of New York but with just a handful of streetlights. That's Dragonfly 44, a shadowy giant lurking in the cosmic dark. But here's where it gets weirder. Despite its enormous size, the galaxy's stars are scattered so thinly that it's almost transparent. If you were flying through it, you might not even realize you were inside a galaxy at all. Astronomers call these ultra-diffuse galaxies, and Dragonfly 44 is one of the most extreme examples ever found. Why does it exist? One theory suggests it's a failed galaxy, a cosmic underachiever that never quite gathered enough gas to form stars efficiently. Another idea is that it's the remnant of a larger galaxy, stripped of its stars by violent collisions or tidal forces over billions of years. Either way, Dragonfly 44 challenges our assumptions about how galaxies form and evolve. And here's the kicker, there might be countless more like it. Recent surveys suggest ultra-diffuse galaxies could be far more common than we thought, hiding in plain sight because they're so faint. Telescopes like the James Webb are now scanning the cosmos for these elusive ghosts, and each discovery forces us to rethink what a galaxy can be. From invisible giants to cosmic rebels, the universe never runs out of surprises. Next up, we'll tackle another hurdle in our quest to understand the earliest galaxies, the cosmic dust that veils them from our view. Now, let's peel back another layer of the cosmic mystery dust. Not the kind you wipe off your shelf, but vast clouds of tiny particles floating between stars, hiding some of the universe's oldest galaxies from view. Cosmic dust might sound insignificant, but it's one of astronomy's biggest headaches when studying early galaxies. These microscopic grains made of carbon, silicon, and other elements absorb and scatter light, especially in the ultraviolet and visible wavelength. That's a problem because the light from the most distant galaxies is already stretched into infrared by the time it reaches us, and dust loves to block infrared too. Imagine trying to spot a lighthouse through thick fog, but the fog also dims your flashlight. That's what astronomers are up against. Here's why it matters. Dust can make young galaxies look older, dimmer, or even completely invisible. Some galaxies in the early universe might be churning out stars at furious rates, but if they're shrouded in dust, their light gets smothered before it can escape. This creates a cosmic game of hide and seek, where telescopes like James Webb have to peer through the dust's veil to uncover the truth. But dust isn't just an obstacle, it's also a clue. The presence of dust in early galaxies tells us something astonishing. These galaxies had already forged heavy elements within just a few 100 million years of the Big Bang. That means stars lived, died, and exploded as supernova, spewing dust into space at a breakneck pace. The universe wasted no time getting messy, so how do we solve the dust dilemma? Astronomers use clever tricks like studying galaxies at multiple wavelengths or looking for telltale signs of dust's fingerprint on their light. Every breakthrough peels back another layer, revealing galaxies that were once hidden in plain sight. Speaking of hidden wonders, our next stop takes us to a group of tiny but mighty galaxies that pack a surprising punch, the so-called green peas. These peculiar cosmic objects might be small, but they're rewriting the rules of star formation. Now, let's turn our attention to something unexpectedly vibrant in the cosmic tapestry, the green pea galaxies. These peculiar little cosmic gems might be small, but they're anything but ordinary. Picture a galaxy so compact it could fit inside the Milky Way's central bulge, yet glowing with an intense green hue like a cosmic emerald. That's the green pea for you, a tiny powerhouse defying expectations. What makes these galaxies stand out isn't just their color. Green peas are star-forming factories, churning out new stars at rates that dwarf our own galaxy's pace. While the Milky Way might produce 1 or 2 stars per year, a green pea galaxy can spawn hundreds, even thousands in the same time. This frenzy of creation lights them up so brightly that they were first spotted by citizen scientists sifting through telescope data, proving that cosmic discoveries can come from anywhere. Their green tint comes from oxygen gas glowing intensely under the radiation of all those newborn stars. It's like a neon sign in the cosmos advertising their explosive activity. But here's the twist, green peas aren't just curiosities, they're time capsules. Many exist in the distant universe, offering a glimpse into how small galaxies behaved billions of years ago, when the cosmos was younger and more chaotic. What's truly mind-bending is how these tiny galaxies challenge our ideas about galactic evolution. Conventional wisdom says massive galaxies dominate star formation, but green peas prove that even the little guys can punch above their weight. Some astronomers think they might be local counterparts to the earliest galaxies, which also blazed with star formation before settling down into quieter maturity. And just when you think they couldn't get more fascinating, green peas have another secret: they're leaking gas. The sheer energy of their star birth can blow holes in their own structures, ejecting material into space like a cosmic sprinkler. This self-destructive brilliance might explain why some galaxies eventually quench, shutting down star formation as they run out of fuel. So next time you think bigger is better, remember the green peas proof that the universe's most dazzling fireworks can come in the smallest packages. Up next, we'll see how the afterglow of the Big Bang itself hides clues about galaxies even more ancient than these emerald powerhouses. Now, let's peel back another layer of cosmic history, this time written in the faint glow of the universe's oldest light. The cosmic microwave background, or CMB, isn't just a relic of the Big Bang. It's a celestial detective holding subtle fingerprints of the very first galaxies. Imagine this afterglow as a cosmic canvas painted 13.8 billion years ago, yet still bearing whispers of structures that formed much later. Here's how it works. As the first galaxies flickered to life, their stars and black holes flooded the universe with radiation. This energy interacted with the sparse gas between galaxies, reheating it in a process called reionization. These temperature fluctuations left faint scars on the CMB, patterns so delicate they're only visible with instruments like the Planck satellite. It's like finding shadows of ancient trees etched into the surface of a fossil. What's astonishing is how these imprints defy expectations. Some patches of the CMB suggest galaxies ignited earlier than our models predicted, hinting at hidden chapters in cosmic dawn. Others reveal vast bubbles where reionization happened unevenly, as if the universe flickered awake like a city at sunrise, one neighborhood at a time. But the CMB's clues don't stop there. By mapping these irregularities, astronomers can trace the distribution of dark matter, the invisible scaffold that guided galaxy formation. Think of it as reconstructing a dinosaur's skeleton from its footprints. The CMB's ripples even hint at exotic physics, like primordial black holes or dark energy's early influence waiting to be decoded. So while the cosmic microwave background might seem like static on an old TV, it's actually a time machine. Every subtle warp tells a story of galaxies being born, of light piercing the darkness, and of a universe far stranger than we ever imagined. Next, we'll meet a cosmic titan so massive it bends the rules of gravity itself. Now, let's turn our gaze toward a true heavyweight of the cosmos, a galaxy cluster so colossal it earned the nickname El Gordo, Spanish for the Fat One. This cosmic titan, officially known as ACDCLJ 01024915, sits a staggering 7 billion light-years away. Yet its sheer size and violence defy everything we thought possible about how such structures form in the early universe. What makes El Gordo so extraordinary? For starters, it's one of the most massive galaxy clusters ever observed at this distance, weighing in at around 3 quadrillion times the mass of our Sun. That's equivalent to 3,000 Milky Ways crammed together in a single, chaotic family. But here's the puzzle. Clusters this huge shouldn't exist so soon after the Big Bang. According to our models, the universe simply didn't have enough time to gather this much matter in one place. Yet El Gordo stands, or rather, collides as a glaring exception. And collide it does. This isn't just a static cluster, it's a cosmic train wreck in slow motion. Observations from the Hubble and Chandra telescopes reveal 2 smaller galaxy clusters smashing into each other at millions of miles per hour. The collision is so violent it rips gas apart, creating a shockwave visible in X-rays, a glowing arc of superheated plasma that stretches across 2 million light-years. It's like watching 2 storms merge into a hurricane, but on a scale that dwarfs imagination. Even stranger is El Gordo's dark matter. During the collision, most of the cluster's regular matter got stuck in the middle, while its invisible dark matter sailed ahead, detected only by how its gravity bends light from more distant galaxies. This separation is a smoking gun, proving dark matter really does behave differently from the stuff we can see. So how did this monster form so early? One theory suggests it grew in an unusually dense pocket of the young universe where gravity worked overtime. Another hints that dark energy, the mysterious force accelerating cosmic expansion, might have played a role by pushing matter together faster than expected. Whatever the answer, El Gordo forces us to rethink our cosmic timelines. Next, we'll confront an even bigger mystery: galaxies that seem to defy the very glue holding the universe together. Now, let's unravel one of the most baffling mysteries in modern astronomy: galaxies that seem to defy the very rules of the universe by existing without dark matter. This discovery has sent shockwaves through the scientific community, challenging what we thought we knew about how galaxies form and hold together. Dark matter, that invisible cosmic glue, is supposed to make up about 85% of all matter in the universe. It's the hidden scaffolding that gives galaxies their structure, keeping stars from flying apart as they spin. But in 2018, astronomers stumbled upon something impossible: a galaxy called NGC 1052 DF2, which appeared to have almost no dark matter at all. At first, many assumed it was a mistake. How could a galaxy survive without the thing that supposedly holds it together? Yet the evidence was undeniable. By measuring how fast its stars moved, researchers realized this galaxy's visible matter alone accounted for nearly all its mass. Without dark matter's gravitational pull, those stars should have been scattered across space. The discovery was so startling that some scientists scrambled to find alternative explanations. Maybe the galaxy was just oddly shaped, or perhaps dark matter had been stripped away by a cosmic collision. But follow-up studies only deepened the mystery. More dark matter-free galaxies were found, like NGC 1052 DF4, each defying expectations in the same eerie way. This isn't just a curiosity, it's a crisis for astrophysics. If galaxies can exist without dark matter, it throws into question our entire understanding of how these cosmic structures form. Some theories suggest these oddballs might be failed galaxies, born in regions where dark matter was unusually sparse. Others propose they're the aftermath of violent encounters, where dark matter was ripped away while stars remained. But the most radical idea: maybe dark matter isn't what we think it is at all. Could there be flaws in our models, or even entirely new physics at play? The debate rages on, but one thing's certain: these enigmatic galaxies are forcing us to rethink the universe's hidden rules. And as we push deeper into the cosmos, who knows what other cosmic rebels we'll find. Next, we'll witness how gravity itself can twist reality, creating illusions that reveal galaxies hidden in plain sight. Now, let's step into a cosmic hall of mirrors where gravity itself bends the rules of light and space. Meet the Pandora's cluster, officially known as Able 2744, a colossal gathering of galaxies whose immense gravity warps the fabric of the universe around it. This isn't just a cluster, it's a natural telescope, magnifying and distorting the light from galaxies so distant they'd otherwise be invisible to us. Here's how it works. According to Einstein's theory of relativity, massive objects like galaxy clusters bend spacetime, causing light to curve as it passes by. The Pandora's cluster is so massive that it acts like a giant lens, twisting the light from background galaxies into surreal arcs, rings, and even multiple copies of the same galaxy. Imagine holding a funhouse mirror up to the cosmos. That's the kind of distortion we're talking about. One of the most stunning examples is a faraway galaxy nicknamed the Dragon, stretched and duplicated into 5 separate images by the cluster's gravity. Astronomers call this effect gravitational lensing, and it's not just a cosmic curiosity, it's a powerful tool. By studying these distorted images, scientists can map the cluster's hidden dark matter, uncovering how this invisible scaffolding shapes the universe. But the Pandora's cluster has even more secrets. Its lensing effect reveals galaxies from the universe's toddler years, some as young as 600 million years after the Big Bang. These magnified snapshots let us peer into an era when the first galaxies were taking shape, offering clues about how our cosmic neighborhood evolved. What makes this cluster truly special, though, is its chaos. Unlike most lensing clusters, which have a neat, symmetrical distortion, Pandora's is a messy tangle of warped light, a sign of a violent past. Collisions between galaxies within the cluster have left dark matter and hot gas strewn about, creating a gravitational funhouse with no two mirrors alike. So next time you hear about gravitational lensing, remember the Pandora's cluster, a place where gravity doesn't just pull, it paints. And as we unravel its distortions, we're not just seeing galaxies far away, we're glimpsing the hidden architecture of the universe itself. Up next, we'll explore a galaxy where stars explode like fireworks, lighting up the cosmos in ways you won't believe. Now, let's turn our gaze to a cosmic spectacle that puts any 4th of July display to shame. Meet the Fireworks Galaxy, a distant starburst galaxy where supernovae erupt with staggering frequency, lighting up the darkness like celestial fireworks. While our Milky Way averages just 1 or 2 supernovae per century, this galaxy churns them out at a rate that's nothing short of explosive. What makes the Fireworks Galaxy so prolific? It's all about the frenzied pace of star formation. This galaxy is a stellar nursery on overdrive, birthing massive stars at a breakneck speed. And here's the catch: the bigger the star, the shorter its lifespan. These colossal stars burn bright and fast, ending their lives in cataclysmic supernova within just a few million years. It's like a cosmic assembly line where stars are born, live, and explode in rapid succession. But the real magic happens when we peer into the aftermath. Each supernova scatters heavy elements like gold, platinum, and uranium across the cosmos, seeding future generations of stars and planets. The Fireworks Galaxy isn't just a light show, it's a forge where the building blocks of life are hammered into existence. Astronomers study this galaxy like detectives at a crime scene, piecing together clues from its frequent explosions. By comparing its supernova rate to quieter galaxies like ours, they're unraveling how star formation and galactic environments shape these violent events. So the next time you look up at the night sky, remember, while our Milky Way may seem calm, there are places in the universe where the sky is always ablaze. And as we'll soon see, even the quietest corners of space hold surprises like a ghostly galaxy that defies everything we thought we knew. Now, let's journey from explosive galaxies to something far more serene yet equally mesmerizing. Picture the Horsehead Nebula, that iconic cosmic silhouette of dark dust against glowing gas, a familiar sight in our own Milky Way. But what if I told you something strikingly similar existed in the early universe, over 13 billion years ago? Deep in the cosmos, astronomers have spotted a distant gas cloud that mirrors the Horsehead Nebula, offering us a rare glimpse into how star-forming regions have evolved since the dawn of time. Just like its modern counterpart, this ancient cloud is a nursery where stars are born, but with one key difference: the conditions back then were far more extreme. In the early universe, gas clouds like this were richer in raw, primordial material, untouched by generations of supernova. Without heavy elements to cool the gas efficiently, star formation was a violent, chaotic process, birthing massive stars that burned fiercely and died young. Compare that to today's Horsehead Nebula, where heavier elements help gas clump together more gently, leading to smaller, longer-lived stars like our Sun. This cosmic time capsule shows us how star birth has matured over billions of years. Back then, these nebulae were like untamed wilderness, while today they're more like cultivated gardens. Yet both share the same breathtaking beauty, a reminder that even as the universe changes, some patterns repeat across the eons. And speaking of patterns, our next discovery takes us to galaxies that seem frozen in time, defying the very laws of cosmic evolution. Now, let's turn our attention to one of the universe's most stubborn survivors, the so-called red nugget galaxies. These cosmic relics are like time capsules, compact and reddish in color, defying expectations by remaining virtually unchanged for billions of years. While most galaxies evolve dramatically over time, merging, growing, or fading, red nuggets have somehow resisted the forces that reshape their peers. Discovered lurking in the distant universe, these galaxies are surprisingly small yet incredibly dense, packing as many stars as the Milky Way into a space far smaller. Their reddish hue comes from aging stars with little of the blue light emitted by young, hot stars. This suggests they stopped forming new stars long ago, freezing themselves in a state that astronomers once thought impossible to maintain for so long. What makes red nuggets truly baffling is how they've endured. In the chaotic early universe, where collisions and bursts of star formation were common, these galaxies somehow shut down their star-making factories early and avoided being torn apart or absorbed by larger neighbors. Some theories suggest their immense density created gravitational fortresses, shielding them from disruption, while others propose they exhausted their gas supplies too quickly to keep forming stars. Yet here they are, ancient, unyielding, and eerily pristine. Studying them is like finding a fossil that hasn't aged a day, offering clues about how galaxies can press pause on their own evolution. And as we unravel their secrets, we're reminded that the universe still holds mysteries that challenge even our boldest theories. Up next, we'll encounter a galaxy so faint it's almost ghostly, another cosmic puzzle waiting to be solved. Now, let's step into the shadows of the cosmos to uncover one of its most elusive mysteries, the ghost galaxy. This faint, wispy giant defies everything we thought we knew about how galaxies form and survive. Imagine a galaxy so dim it's almost invisible, yet so massive it rivals our Milky Way in size. That's the enigma of the ghost galaxy, a cosmic phantom that barely emits any light, yet holds an astonishing amount of mass. Discovered lurking in the distant universe, this galaxy is like a whisper in the dark. Most of its matter is spread out in an incredibly diffuse structure, making it nearly undetectable against the black backdrop of space. Unlike typical galaxies, which glow brightly with stars and gas, the ghost galaxy is eerily transparent, with stars so thinly scattered that you could fly right through it without noticing. What makes this galaxy truly baffling is how it even exists at all. According to our current understanding, galaxies need dense clumps of dark matter to hold their stars together. But the ghost galaxy's dark matter seems to be spread so thinly that it shouldn't be able to keep its stars from drifting apart. Yet somehow, it endures, challenging our models of galactic formation and forcing astronomers to rethink the rules. Some theories suggest it might be a failed galaxy, one that never gathered enough gas to ignite star formation on a large scale. Others propose it could be the remnant of a violent collision, its stars scattered but still bound by invisible threads of dark matter. Whatever the case, the ghost galaxy stands as a haunting reminder that the universe still holds secrets we've only begun to glimpse. Up next, we'll witness a cosmic collision of epic proportions, two galaxies locked in a dance of destruction and rebirth. Now, let's turn our gaze to one of the most dramatic events in the cosmos, a celestial showdown where two galaxies become locked in a gravitational embrace. This is the Medusa merger, a violent collision that unfolded billions of years ago, offering a glimpse into the chaotic dance that awaits our own Milky Way and the Andromeda Galaxy in the distant future. Picture two massive galaxies, each brimming with stars, gas, and dust spiraling toward one another. As they draw closer, their mutual gravity twists and warps their shapes, stretching them into long, luminous tendrils that resemble the serpentine hair of the mythical Medusa. These tidal tails, glowing with newborn stars and superheated gas, are the aftermath of a cosmic tug of war where neither galaxy escapes unscathed. What makes the Medusa merger so fascinating is how it mirrors the fate of our own galactic neighborhood. In about 4 billion years, the Milky Way and Andromeda will undergo a similar collision, merging into a single, colossal galaxy. But here's the twist: while these crashes look catastrophic, they're actually creative forces. The chaos of the Medusa merger triggers bursts of star formation, as clouds of gas collide, compress, and ignite into new stellar nurseries. Yet, despite the violence, individual stars rarely collide. Galaxies are mostly empty space, so stars slip past one another like ships in the night. Instead, it's the galaxy's structures that are torn apart and reshaped, eventually settling into a new, blended form. The Medusa merger shows us that destruction in the cosmos often leads to rebirth, a reminder that even in the vastness of space, change is the only constant. Up next, we'll meet a galactic predator whose black hole unleashes a deadly cosmic storm. Now, let's shift our focus to a galactic menace lurking in the depths of space: the Black Widow galaxy, a cosmic predator with a deadly appetite. This distant galaxy harbors a supermassive black hole at its core, but unlike most, it doesn't just consume matter quietly. Instead, it acts like a celestial assassin, firing lethal beams of radiation across the cosmos. Imagine a spider at the center of a web, but instead of silk, it spins out high-energy jets that can stretch for thousands of light years. These jets, powered by the black hole's immense gravity, blast nearby galaxies with intense X-rays and gamma rays, stripping them of the gas needed to form new stars. Over time, this radiation stifles star formation, leaving victim galaxies starved and stagnant, trapped in the Black Widow's deadly grip. What makes this galaxy so sinister is how it mirrors its namesake. Just as a Black Widow spider dominates its environment, this galaxy suppresses the growth of its neighbors, ensuring it remains the dominant force in its cosmic neighborhood. Astronomers believe such predatory behavior might explain why some regions of the early universe have oddly dead galaxies, their star-forming potential snuffed out far too soon. Yet, there's a twist: this destruction might also shape cosmic evolution. By clearing out weaker galaxies, the Black Widow galaxy could be carving out space for larger structures to form, proving once again that even the most violent forces in the universe play a role in its grand design. Coming up, we'll journey to a frozen corner of the cosmos where extreme cold somehow fuels an explosion of stellar birth. Now, let's venture into one of the universe's most puzzling contradictions: the Snowball Galaxy, a cosmic enigma where freezing temperatures somehow spark a firestorm of star birth. At first glance, this distant galaxy defies logic. How can a place so cold become a hotbed of stellar activity? Most galaxies form stars in warm, dense clouds of gas, but the Snowball Galaxy flips the script. Here, temperatures plunge so low that molecules move sluggishly, yet against all odds, stars erupt in dazzling numbers. Astronomers believe the secret lies in the galaxy's unique environment. Its frigid clouds are packed with unusually high amounts of molecular hydrogen, a key ingredient for star formation. When these clouds collapse under their own gravity, the sheer density overcomes the cold, igniting a frenzy of stellar creation. What's even more fascinating is how this icy star factory challenges our understanding of galactic evolution. Typically, extreme cold stifles star birth, but the Snowball Galaxy proves that under the right conditions, the rules can bend. Some theories suggest that ancient collisions or hidden streams of dark matter might be compressing its gas, turning a cosmic deep freeze into a stellar nursery. This galaxy isn't just a curiosity, it's a reminder that the universe loves surprises. Even in the most inhospitable corners of space, nature finds a way to create brilliance. Next, we'll uncover a galaxy that rose from the ashes, reigniting its star-forming engines after billions of years of silence. Shifting our gaze to another cosmic marvel, we encounter the Phoenix Galaxy, a celestial phoenix that defied expectations by bursting back to life after eons of stillness. This distant galaxy spent billions of years in a dormant state, its star-forming gas seemingly exhausted until something extraordinary happened. Against all odds, it reignited, sparking a new wave of stellar birth that left astronomers stunned. The Phoenix Galaxy's rebirth challenges what we know about galactic life cycles. Most galaxies that exhaust their star-forming fuel fade quietly into the cosmic background. But this one found a way to replenish its gas, possibly by siphoning fresh material from intergalactic space or merging with a smaller, gas-rich neighbor. The result, a spectacular resurgence with newborn stars blazing across its spiral arms like fireworks. What makes this revival even more intriguing is the timing. The Phoenix Galaxy's reawakening occurred relatively late in cosmic history, long after the universe's peak era of star formation. This suggests that galaxies might have hidden reservoirs of resilience, or that external forces can breathe new life into them when conditions align. Some scientists speculate that its central black hole, once dormant, might have stirred, heating surrounding gas and triggering a cascade of new star birth. The Phoenix Galaxy doesn't just tell a story of revival, it hints at untapped possibilities. If galaxies can rise from the ashes, what other surprises might the universe hold? Next, we'll delve into a galactic thief, a cosmic predator that grows by stealing stars from its neighbors. Now let's turn our attention to a cosmic thief lurking in the depths of space, the Vampire Galaxy. Unlike the Phoenix, which found new life through rebirth, this distant galaxy thrives by stealing stars straight from its neighbors. Picture a celestial predator, silently siphoning away the light of other galaxies to fuel its own growth. The Vampire Galaxy doesn't just drift peacefully among its peers, it actively strips stars from smaller, weaker galaxies that wander too close. Gravity does the dirty work, pulling entire streams of stars away from their homes and into the vampire's grasp. Over time, these stolen stars swell its size, leaving the victim galaxies dimmer and depleted. What's truly fascinating is how common this behavior might be. Astronomers suspect many large galaxies, including our own Milky Way, grew in part by absorbing smaller ones. But the Vampire Galaxy takes it to extremes, with visible trails of stolen stars stretching across space like cosmic breadcrumbs. These ghostly streams are evidence of past heists, revealing a history of galactic plunder. The most surprising part, the Vampire Galaxy isn't just a bully, it's a survivor. By cannibalizing its neighbors, it secures the resources needed to endure in a universe where only the adaptable thrive. This ruthless strategy might even explain how some of the universe's earliest galaxies grew so massive so quickly. Up next, we'll explore a galaxy with a tale so dramatic, it tells the story of an ancient collision that shaped its fate. Now let's shift our gaze to a galaxy that wears its history like a badge, the Tadpole Galaxy. Unlike the stealthy theft of the Vampire Galaxy, this distant cosmic wonder flaunts a spectacular tale of stars stretching across space, a shimmering scar from a violent encounter billions of years ago. Picture a celestial tadpole, its bright head glowing with young stars, while behind it, a winding stream of stars and gas stretches over 280,000 light-years, nearly twice the length of our Milky Way. This tale isn't just for show, it's the aftermath of a galactic collision where a smaller galaxy strayed too close and was torn apart by gravitational forces. The Tadpole Galaxy didn't just survive the crash, it absorbed its victim, leaving behind this glittering trail as a cosmic fingerprint. What makes this even more fascinating is how the tale acts like a time capsule. The stars within it are older and redder than those in the tadpole's core, hinting at the original galaxy's age before it was disrupted. Meanwhile, the tadpole's main body buzzes with newborn stars, likely ignited by the shockwaves of the collision. It's a snapshot of destruction and rebirth, frozen in the depths of space. Astronomers study galaxies like this to understand how cosmic crashes shape evolution. The tadpole's tale shows how even chaos can create beauty. weaving streams of stars that might one day form new galaxies or fuel future collisions. And here's the twist: our own Milky Way may have sported a similar tale long ago after its own ancient encounters. Next, we'll unravel the mystery of a galaxy so perfectly shaped, it looks like it was crafted by the universe's own hands. Now, let's turn our attention to a cosmic marvel that seems almost too perfect to be real: the Ring Galaxy. Imagine a celestial jewel, a galaxy so precisely shaped it appears as if it were drawn with a compass. This rare and stunning structure, a near-perfect circle of stars glowing in the depths of space, defies the chaotic norm of galactic shapes and leaves astronomers in awe. The secret behind this flawless ring: a head-on collision, one of the most violent events in the universe. Picture a smaller galaxy plunging straight through the heart of a larger one, like a bullet through a target. The impact sends shockwaves rippling outward, compressing gas and dust in its wake. This compression triggers a frenzy of star formation, lighting up a brilliant ring around the galaxy's now disrupted core. Over time, the ring expands, creating the illusion of a cosmic pulse suspended in the void. What's even more fascinating is how these ring galaxies challenge our understanding of galactic evolution. Unlike the messy mergers that create twisted spirals or clumpy ellipticals, ring galaxies are a testament to precision amid chaos. The stars in the ring are often younger and bluer, born from the collision's aftermath, while the galaxy's center, if it survives, harbors older, redder stars, a quiet relic of what once was. Astronomers study these rare gems to unravel the physics of high-speed collisions. The Ring Galaxy isn't just a pretty face, it's a laboratory for testing how galaxies rebound from catastrophic encounters. And here's a thought to ponder: our own Milky Way might one day face a similar fate when it collides with the Andromeda Galaxy. Will it too wear a ring of fire? Next, we'll dive into the explosive heart of a distant galaxy where gas surges outward at unimaginable speeds, painting a portrait of cosmic fury. Now, let's shift our gaze to a galaxy that's anything but calm: the Cigar Galaxy, a cosmic powerhouse blasting gas into the void at speeds that defy imagination. This distant marvel isn't just burning bright. It's erupting with colossal streams of superheated gas shooting outward like fireworks on a cosmic scale. What's fueling this fiery spectacle? The answer lies in two of the universe's most violent phenomena: supernova and a ravenous central black hole. Picture a galaxy where stars aren't just born, they explode in spectacular supernova, one after another, each detonation sending shockwaves that hurl gas into intergalactic space. These explosions are so frequent and intense that they create a relentless wind, a storm of particles racing outward at millions of miles per hour. But that's only half the story. Deep in the galaxy's heart, a supermassive black hole feasts on surrounding matter, heating it to unimaginable temperatures before ejecting it in jets of energy that stretch far beyond the galaxy itself. What makes the Cigar Galaxy so special is how these two forces, supernova and the black hole, work in tandem. The combined energy sculpts the gas into vast, glowing outflows visible across cosmic distances. Astronomers study these outflows like forensic scientists, piecing together clues about how galaxies recycle their material into the cosmos. Some of this ejected gas may never return, seeding future generations of stars in entirely different galaxies. Here's the twist: these outflows aren't just destructive, they're a galactic self-regulation system. By expelling gas, the Cigar Galaxy might be slowing its own star formation, preventing it from burning out too quickly. It's a reminder that even in chaos, there's balance, a dance of creation and destruction that shapes the universe. Next, we'll journey to a galaxy that mirrors one of our own cosmic neighbors, revealing how the past and present of galactic design are intertwined. Now, let's turn our attention to a cosmic mirror, a glimpse into how the universe's grand designs have transformed over billions of years. Meet the Whirlpool Galaxy's ancient twin, a spiral galaxy from the early universe that challenges our expectations of how these majestic structures evolve. The Whirlpool Galaxy, known for its stunning, well-defined arms swirling around a bright core, is a poster child for modern spiral galaxies, but its ancient counterpart, discovered lurking in the distant cosmos, tells a different story. This early universe version shares the same basic blueprint, a spinning disk with spiraling arms but with a twist. Its structure is looser, more chaotic, as if the galaxy hasn't yet settled into the elegant symmetry we see today. Why the difference? Gravity's patient work. Over eons, the pull of dark matter and the gentle dance of stars and gas gradually sculpted these early spirals into the tighter, more organized forms we recognize now. The ancient twin's arms are patchy, its core less defined, a snapshot of galactic adolescence. Yet, despite the messiness, it's unmistakably a spiral proof that the universe began crafting these intricate designs far earlier than we once thought. Here's what's truly fascinating. Even in its youth, this galaxy was already forming stars at a furious pace, much like the Whirlpool does today. The ingredients were there: gas, dust, and gravity, just waiting to coalesce into the familiar patterns we adore. By studying these ancient twins, astronomers pieced together how spiral galaxies grew up, refining their shapes while maintaining their star-making magic across cosmic time. Next, we'll uncover another distant galaxy that echoes a modern icon, this time with a shape so distinctive it's impossible to forget. Now, let's journey to another cosmic surprise, a galaxy so striking it seems to defy time itself. Far across the universe, astronomers have spotted a distant doppelganger of the iconic Sombrero Galaxy, a celestial marvel we thought was unique to our cosmic neighborhood. The Sombrero Galaxy, with its broad, dust-rich brim and glowing central bulge, is one of the most recognizable galaxies in the modern universe. But its ancient twin, shining from the depths of space, reveals something extraordinary. This distinctive shape existed billions of years earlier than we imagined. This primordial version shares the same dramatic silhouette, a bright core encircled by a dark, sweeping disk of dust, but with a youthful energy. What makes this discovery so thrilling? It challenges the idea that such polished galactic forms took ages to develop. Instead, this ancient sombrero suggests that some galaxies achieved their signature looks early, even in the universe's chaotic youth. The dust lanes are there, the central bulge is forming, proof that the ingredients for elegance were present from the start. Yet there's a key difference. This early sombrero is a star-making powerhouse, its dust and gas fueling frenzied stellar birth. Over time, as its raw materials were used up or blown away, it likely settled into the calmer, more refined state we see in its modern counterpart. This cosmic mirror shows us that while galaxies evolve, some of their most stunning features might be timeless. Next, we'll encounter yet another distant galaxy with a familiar face, one that spins a tale of cosmic artistry across the ages. Shifting our gaze to another cosmic wonder, let's unravel the story of a distant galaxy that mirrors one of our most beloved celestial sights, the Pinwheel Galaxy. Known for its stunning, symmetrical spiral arms, the Pinwheel Galaxy is a masterpiece of the modern universe. But billions of light-years away, its ancient cousin spins a tale that rewinds the clock, proving such intricate designs grace the cosmos far earlier than we ever imagined. This faraway twin, though older, shares the same breathtaking blueprint, elegant arms swirling outward from a luminous core, a testament to the universe's knack for crafting beauty across time. What's remarkable is how these delicate structures endured the chaos of the early cosmos, where violent collisions and rampant star formation should have torn them apart. Instead, this ancient spiral stands as a cosmic fossil, preserving the artistry of a younger universe. The secret lies in its balance. While modern spirals like the Pinwheel Galaxy owe their grace to slower, steadier growth, this primordial version thrived amid turbulence. Its arms, though less defined, are already tracing the same graceful arcs, suggesting the forces shaping galaxies today were at work even then. Gas and dust drawn into these swirling patterns ignited bursts of star formation, lighting up the spiral like a cosmic pinwheel in motion. Yet there's a twist. This ancient spiral is more than just a pretty face. Its rapid star production hints at a time when galaxies were richer in raw materials, fueling fiercer stellar births than we see in their modern counterparts. Over eons, as these resources dwindled, spirals like the pinwheel galaxy settled into their quieter, more refined states. But their distant cousins remind us the universe has always had a flair for grand design. Next, we'll witness a collision of cosmic titans, where two galaxies clash in a spectacle that reshapes our understanding of the early universe. Now, let's turn our attention to a cosmic spectacle that reveals the raw power of galactic collisions, the antennae galaxies. These two spirals, locked in a violent embrace, offer a glimpse into the chaos that shaped the early universe. Their name comes from the long, streaming tails of stars and gas flung outward by the collision, resembling the delicate antennae of an insect. But don't let the poetic name fool you. This merger is anything but gentle. What makes the antennae galaxies so fascinating is how they mirror the fate awaiting many galaxies, including our own Milky Way. Billions of years ago, such collisions were far more common, as the denser early universe forced galaxies into frequent, dramatic encounters. The antennae pair shows us the aftermath of one such crash, a fiery burst of star formation ignited as their gas clouds compressed and ignited. Yet this merger isn't just about destruction. It's a creative force. The chaos births new star clusters at a staggering rate, some so massive they'll likely become globular clusters, ancient stellar cities that will orbit the merged galaxy for eons. The antennae also preview what happens when two galaxies become one. Over time, their cores will merge, their twisted arms will settle, and a new, larger galaxy will emerge, a process we've seen echoed in younger galaxies across the cosmos. What's truly remarkable is how these ancient collisions left their mark on the universe. The antennae's violent dance isn't just a relic of the past, it's a blueprint. Similar mergers helped build the giant ellipticals we see today, proving that even in chaos, the universe follows a grand, repeating pattern. Next, we'll explore another distant galaxy whose bizarre shape tells a story of cosmic impact, one that turned it into a celestial wagon wheel. Now, let's roll into one of the most striking cosmic accidents ever witnessed, the Cartwheel Galaxy. This distant marvel looks like it was stamped into space by a giant wagon wheel, but its perfect shape wasn't crafted by design. Instead, it's the aftermath of a head-on collision so violent it sent shockwaves rippling through the galaxy, reshaping it into a celestial bullseye. What makes the Cartwheel Galaxy extraordinary is how clearly it shows the aftermath of a high-speed crash. Roughly 200 million years ago, a smaller galaxy likely tore right through its center like a bullet through smoke. The impact sent waves of gas and dust rushing outward, compressing material into a blazing ring of newborn stars. This glowing outer ring, dotted with brilliant blue star clusters, is the galaxy's most iconic feature, a cosmic ripple frozen in time. But the collision didn't just create a pretty pattern. It scrambled the galaxy's entire structure. The cartwheel's inner regions were left twisted and turbulent, while the outer ring races outward at staggering speeds. This isn't just a static snapshot, it's a dynamic transformation still unfolding. Telescopes reveal pockets of intense star formation, where collapsing gas clouds ignite like fireworks along the expanding ring. What's even more fascinating is how rare this event was. Most galactic collisions are glancing blows, like the antennae galaxies we just explored. But the Cartwheel's direct hit offers a front-row seat to a more extreme cosmic demolition. It's a reminder that the early universe was a demolition derby, where such violent encounters sculpted galaxies into shapes we're still discovering today. Up next, we'll spin toward another distant wonder, a galaxy whose swirling arms bloom like petals in the cosmic dark. Now, let's turn our gaze toward a cosmic bloom, the Sunflower Galaxy, a distant masterpiece that mirrors nature's artistry. Picture a sunflower swaying in a field, its golden petals spiraling outward from a radiant center. This galaxy, officially known as Messier 63, unfolds in much the same way, with luminous arms swirling gracefully around a brilliant core, creating a celestial echo of Earth's floral beauty. What makes the Sunflower Galaxy truly captivating is its intricate structure. Unlike the chaotic clumps of early galaxies, this one boasts well-defined, symmetrical arms, each brimming with young, hot stars that glow blue against the cosmic backdrop. These arms aren't just pretty, they're stellar nurseries where dense pockets of gas collapse to ignite new stars, much like seeds sprouting along a sunflower's spirals. But here's the twist: the Sunflower Galaxy isn't just a static portrait. Its arms are dynamic, shaped by gravitational interactions with neighboring galaxies over billions of years. Some astronomers believe a close encounter long ago stretched and sculpted its structure, leaving behind this mesmerizing pattern. And while it may look serene, the galaxy's core hides a supermassive black hole, silently shaping the dance of stars around it. What's remarkable is how this distant galaxy offers a glimpse into the universe's artistic side. It reminds us that even in the vast, impersonal cosmos, nature's patterns repeat, from the spirals of sunflowers on Earth to the grand designs of galaxies millions of light-years away. Up next, we'll peer edge-on at a galaxy that reveals its secrets in silhouette, the Needle Galaxy. Now, let's tilt our perspective to see a galaxy from an entirely different angle. The Needle Galaxy, a cosmic sliver that hides its brilliance in plain sight. Unlike the face-on spirals we often admire, this galaxy presents itself edge-on, appearing as a thin, luminous needle stretched across the darkness of space. This unique vantage point offers astronomers a rare opportunity to study its hidden anatomy, like peering at the spine of a book rather than its colorful cover. What makes the Needle Galaxy so fascinating is how its edge-on orientation unveils secrets most galaxies keep tucked away. The thick lane of dust running along its equator becomes starkly visible, a dark river cutting through the glow of billions of stars. This dust isn't just cosmic debris. It's the raw material for future stars, and its distribution tells us how galaxies recycle matter over time. By measuring how light filters through this dusty veil, scientists can even calculate the galaxy's mass and the density of its star-forming regions. But the surprises don't end there. The Needle Galaxy's flattened profile also reveals the delicate warp of its disk, a subtle bend often caused by gravitational tugs from neighboring galaxies. It's like spotting a slight curve in a vinyl record, hinting at unseen forces at play. And while its spiral arms are nearly invisible from this angle, their presence is betrayed by the faint glow of young stars scattered above and below the dust lane, like fireflies hovering around a shadowy ribbon. This edge-on view reminds us that perspective is everything in astronomy. A single shift in angle can transform a galaxy from a whirlpool of light into a cryptic streak, each offering its own clues about the universe's grand design. Next, we'll catch the ancient light of a familiar neighbor, the Andromeda Galaxy, and discover how its journey through time connects us to the cosmos's earliest days. Now, let's bring our cosmic journey full circle with a galaxy that feels almost like a neighbor yet carries light from an era when the universe was young. The Andromeda Galaxy, the closest spiral galaxy to our Milky Way, may seem nearby at just 2.5 million light-years away, but its light tells a story that stretches back to a time when the cosmos was a very different place. When the photons we see today began their journey, Earth's continents were still forming, and the first galaxies were blazing trails through the primordial darkness. What's astonishing is how Andromeda serves as a bridge between the ancient and the familiar. Its light, though newer than that of the distant galaxies we've explored, still dates back to an epoch when the universe was less than half its current age. By studying Andromeda's oldest stars and globular clusters, Astronomers have uncovered relics from that early era stellar fossils that mirror the conditions of the first galaxies. These ancient stars burn faintly, their compositions revealing the universe's chemical infancy, when elements heavier than hydrogen and helium were rare treasures. Andromeda's size and structure also offer clues about how galaxies evolved. Unlike the chaotic, clumpy galaxies of the early universe, Andromeda's majestic spiral arms and dense central bulge show the refined order of a mature galaxy. Yet hidden in its outskirts are streams of stars' telltale scars from past collisions with smaller galaxies, evidence that even this titan grew by consuming others, just as our Milky Way did. Perhaps most poetic is the fate that awaits Andromeda and our galaxy. In about 4 billion years, the two will collide, merging into a single, colossal galaxy. This future encounter reminds us that the cosmos is never static. It's a living tapestry of creation and destruction, where even the light from our closest galactic companion carries echoes of the distant past. As we conclude our voyage through these 50 awe-inspiring facts, remember that every galaxy, from the farthest whispers of light to Andromeda's shimmering spiral, is a chapter in the universe's grand story. Each discovery peels back another layer of mystery, inviting us to keep looking up and wondering what else lies hidden in the cosmic dark. If this journey through space and time sparked your curiosity, don't forget to subscribe and share your favorite fact below, because the universe always has more secrets to reveal. As we wrap up this cosmic odyssey, let's take a moment to marvel at how these 50 glimpses into the universe's most distant galaxies have reshaped our understanding of space and time. From the fiery birth of the first stars to the silent dance of colliding giants, each fact has revealed a piece of the puzzle, showing us a cosmos far more dynamic and mysterious than we ever imagined. These ancient galaxies aren't just relics of the past, they're active storytellers, whispering secrets about how everything from the tiniest atoms to the grandest structures came to be. What's truly humbling is realizing how much we've yet to discover. Every telescope pointed at the sky, every new observation, peels back another layer of the universe's grand narrative. Whether it's the enigma of dark matter, the rebellious galaxies defying our models, or the cosmic miracles like gravitational lenses bending light across eons, each mystery invites us to keep exploring, questioning, and wondering. So as we close this chapter, remember, the universe isn't just out there, it's unfolding in real time, and you're part of the story. If these facts ignited your curiosity, why not join the journey? Hit that subscribe button to stay updated on the latest cosmic revelations, and drop a comment below sharing which galaxy fact blew your mind the most. Together, let's keep reaching for the stars, because the next great discovery might be just a telescope's gaze away.